Okay, I welcome you all for the session. In this playlist, I am going to teach the PUC first year mathematics subject for the science students according to Karnataka syllabus. And now, the reason for making this video course right now because of it will be helpful for the 11th class students for preparing their examinations, and also these videos or these course structures will be helpful for the 10th students, and they can prepare for summer vacations. Okay, they can prepare these course in the summer vacation. Okay, in the summer vacation they can prepare for this um, this course. Okay, the first very chapter. So this syllabus is according to 2002 23 and 24 revised syllabus. According to that, the syllabus, all topics will be covered, and these topics will be covering the easy understanding of the concept, and according to that, solution of the problems, and solving the exercise problems, and solving the previous question paper problems. So totally these course will be helpful for all type of the students, all level of the type of the students. So this course will be very helpful to score the marks in examination, and also they can develop their understanding of mathematics also. Okay, the first very chapter we'll be going to discuss is on sets. Okay, so sets, as the name itself, so will be sets is nothing but a collection. Okay, so the meaning of sets is what? It's collections. But we define mathematically sets as a, so it is a, we define sets as a, it is a well defined, defined collection of objects, collection of objects. Okay, this is the proper definition of sets. So these objects, it may be things, or it may be matters, or it may be items. Okay, whatever it may be, because all these are synonyms. Okay, all the words are synonyms. And usually in our daily life, we will be seeing the example of collection of the items, collection of the money, and collection of the animals, the um collection of grains, and collection of all the many examples. Okay, we can in our daily life we will be collecting many things in a proper way. So likewise in mathematics also, we do the we are also doing the collection of some points or numbers. So for example, collection of natural numbers. Okay, collection of natural numbers. So natural numbers are infinite. We'll be in the problem sometime what we'll do, we'll be collecting the natural numbers which are less than 10, and the numbers, and also the collection of natural numbers less than 10, odd numbers, and even number of natural numbers which are less than 10. So these are examples of the sets. Okay, I will be giving example here, that so here, and so prime number also is a, so we can give an example of a prime number. So prime number is also a collection of the prime numbers is also an example of a set. So prime numbers, what is the definition of prime number? So prime number are those numbers which will be divided by its own number, and its own number, it will be divided by its own number, it will be divided by its own number and by 1. Okay, suppose you take any number, it will be divided by its own number and by 1. So 1 will not take as a prime number, and every number will be divided by 1. And here 2, 2 is a prime number, 2 will be divided by 2 and by 1, and by other numbers it will not divide. And next is 3, 3 also not divided by other number. 4, 4 will be divided by 2, then 4 is not a prime number. 2, 3, 5, 7, 9, next 8 is not a prime number, it will be divided, 9 will be divided. So likewise we can write number of the number of prime numbers. And the next is, and suppose I will give an example of factorize the 210. Okay, factorize the number 210 by the prime numbers. Okay, prime numbers, I will factorize this. What are the collection of prime numbers will come when I will factorize this number? What are the collection of prime numbers will come? So this will be divided by 2, right? Because it's a even number, then it will be divided by 2. So 2 ones are here, 1 is less than the 2, then 0, 2 5s are 10. So then next is it will not divide by 2 because it contains odd number. Then I will take 3 here. So 3 3 9, 3 3 is a 9 and 1 remains, so 15. 3 5 is a 15. Okay, then next 35. 35 will not divide by 3. Then I will take here 5. 5 7 is a 35. Then 7 remains, 7 divided by 1. Okay, so 2 3 5 sevens are the collection of the sets. 2 3 5 7 is the collection of set when you are factorizing 210. You just write in a sentence, when we are factorizing 210, so we'll be getting a set of prime number as 2357. And one more example is here, when suppose uh, if we are writing, if we are, so suppose if the prime number, suppose okay, suppose when we are factorizing some number, so the some numbers and the prime numbers are coming as 2 2 and 3 5 7. And how we can write here set of a uh, set of condition or set of number? So I will write 2 3 5 7 because the numbers which the elements which are repeated, so we cannot write in the set. So this is the one condition. Okay, so this is one condition. And we represent, we always used to represent a set, a collection of set by the capital letters A B C D. If we are expressing any problems, then we are writing a set in a capital letters, and respective of elements will be writing in a uh, small letters. If it is alphabets, then we will be writing a collection of items. For I will be write a set. Okay, set A, which consists of elements A, B, C, D. Elements I will write in the small letter. Okay, A, B, C, D. Then here the elements will be writing by separating with the commas. By separating with the commas, and a set always represents in a curly brackets. Okay, is always represents in a curly brackets. This is the one condition. Okay, and one more is that, so here set we are a set will be representing in two forms. Okay, the set will be representing in two forms. Will be representing in two forms. In two forms. So one is that, so one is already we discussed about that. So roster or tabular form. Okay, roster or tabular form. So what the problems we have been previously discussed in this here, this is in roster form, and this is in also roster form. Okay, this is in roster form, and the this is in roster form. And the second one is set builder form. Okay, we'll be expressing the sets in a form of set builder form. So set builder form. So we set builder form usually writing in the, okay, suppose set A, and I'm writing set builder form. So x ratio of x is a is a is a prime number, is a prime number, and so, and x is lies between lies between lies between less than 10. Okay, this is the statement I have written here. So usually the set builder form will be writing as like roster form in the curly bracket, and we'll be writing here. So x is means what? As set of all x. Okay, set of all elements of this is all of sets in x form, and x is the characteristic property. This is the characteristic property, and this is the description. Okay, this is the description. This is the description. And if we are uh, this one we are writing in a roster form. This one if we write a roster form, how it will come? It will come as a the prime number which are less than 10. So 2 3 5 6 7, 2 3 5 7 are the prime numbers less than the 10. You understood how to write the prime numbers and wholes prime numbers, how to write the roster and set builder forms. Next, we'll be going to discuss some symbols which are very important in sets, and throughout the mathematics, these symbols are commonly used. Those symbols are N and Z, Q, and capital R. Okay, so these symbols are very important, and these will be used throughout the mathematics. Just remember of this. This capital N is nothing but a set of all natural numbers. Set of all natural numbers. Set of all natural numbers. So natural numbers are those numbers are positive numbers. These are the positive numbers. So without zero, without containing zero. So zero is not a natural number. So other than the zero are the positive numbers are the natural numbers. If we write 1, 2, 3, 4, and so on. Yeah. Okay, and Z is a set of all integers. Okay, is a set of all integers. So set of all integers. So integers are those numbers which contains both negative and zero and positive integers. Negative, positive, and zero integers. Okay, and this Q is the set of all rational numbers. So set of all rational numbers. So rational numbers are in the form of ratios. Okay, in the form of ratios, 1 by 2, 3 by 2, 5 by 7. Such numbers are called rational numbers. And R is a set of all real numbers. Okay, set of all real numbers. Real numbers are those numbers which contains both rational numbers and irrational numbers. Okay, rational and irrational number it contains. So rational number we have already discussed, which are in the form of ratios, and irrational numbers which are not in the form of rational. Okay, other than the rationals are irrational numbers. Usually we representing irrational numbers in the square root of 2, square root of 5, and also by mathematical constant, pi, Euler number. These are the mathematical constant. These are we are having value. So okay, these are some experimental value or constant values we will be having. So value of pi is 3.142, and value of Euler number is what? 2.148. Okay, this is all about uh, this is all about uh, the sets and its representation. Okay, by we'll be taking some example, and you will be understanding the problems. Okay, you will be understanding the problems. So I will take here one example. The first example I will be taking here is, so you just take it, this one is example one. So in example, uh, just write a statement. Write the solution. Okay, write the solution of equation. So the quadratic equation is given x square plus x then minus 2 is equal to 0 in a roster form. Okay, we have to write a set of, when you are solving this equation we'll be getting the x values, and that one we have to write in a roster form. So roster form, before that we need to solve these problems, because solving the quadratic equations by just write as by solving quadratic equation quadratic, you write just in full sentence. Okay, quadratic equation x square plus x minus 2 is equal to 0. You know about how to solve the quadratic equations. Quadratic equations usually first and last term, okay, will be multiplies. 2 into x square minus 2x square. Signs also, signs positive and negative signs we have to consider. Positive into negative, what? Negative. And when we are multiplying this number with two numbers, then this number has to become, when we are adding the numbers, okay, when we are multiplying two numbers, this has to come, and when we are adding these two numbers, this middle number has to come. Okay, so what we can take, so we can take here 2x into minus 1x. So 2x into minus 1x is minus 2x squared. And if we are adding these numbers, x will remain. Okay, I can write that one. Okay, so x square plus 2x minus x minus 2 is equal to 0. And next is that, so here I will be taking x as a common, then x remains, and here 2 remains. Okay, x, if I take x common, then x, one x term will be, and here 2 will be remains, because x is I'm taking common out. And again here I will take minus common, minus 1, because the same term has to repeat here. Therefore we need to take care of whether we have to take positive or negative signs. uh, uh, like the number, it has to repeat, this number has to repeat, like that we have to take the signs. And then if we take the minus sign, then it will come as, both are negative terms, then it will come as x plus 2 is equal to 0. These two terms are common, then we'll write uh, as one time x minus 1, this is x minus 1, and this one we are writing one time x plus 2 is equal to 0. And this one we can, how we can write, x minus is equal to 0 and x plus 2 is equal to 0, and x is equal to 1 and x is equal to minus 2. So the set of number is, the set of number in a roster form is just is 1 comma minus 2. Okay, we are solving the second problem, second numerical. So second numerical, sorry, the second numerical. So write a set in a roster form. Okay, write a set in a roster form. Write a set in a, the set is given in a builder form. Okay, the set builder form. Set builder form, that is x, x such that, so this column means what, such that. Okay, the set x such that x element, so x element is a positive integer, is a positive integer, integer, positive integer, and x square is less than the, x square is less than the 40 in a roster form. Okay, we have to write in a roster form. The given problem is given in a set builder form, and we have to write in a roster form. So here x square is less than 40 means you uh, take square of positive integers, take square of positive integers which are less than the 40. Then 1 square is 1, 2 square, 3 square, 4 square, 5 square, 6 square is 36. 7 will not come, 7 will be 49, it is greater than the 40, then it will not come. Then we write this problem as you set a, you just write. Okay, so the numbers are 1 2 3 4. Okay, so this is in the form of n square. Okay, so this is in the form of n square. So this is in the form of n square. Then we can write this as we can write this as so we can write this as so we can write this as in a roster form we have to write. So then it is 1 2 3 4 5 6. Okay, this is the solution of the solution of the second problem. Okay, so so the numbers are the the x numbers are 1 2 3 4 5 6. Okay, then take third example. Okay, take third example. We are taking third example. So third example, a set is given A in the form of 1 4 9 25 16, sorry, 16 25 so on, so on. Okay, so on is dot, this dot dot means what, continues. Okay, this dot dot in continues in a set builder form. So we have to write express this the given roster form into a set builder form. So we found that we can write a set equation as so we can write in a set builder form as set builder form. How we can write x is x contains such that x is the square of natural numbers, is the square of, this is the description, square of natural numbers. And also we can write as these numbers are continuous, then also we can write a is equal to x is equal to of n square, n squared, and where and where the small n is belongs to capital N. Okay, so natural numbers, we don't natural numbers are infinite, so all numbers are belongs to natural numbers. So here in the sentence we can write as a xx is a square of natural numbers. These are the square of natural numbers. Okay, then we can write this xx is equal to n square, where n is belongs to n. Okay, we can write this. And the next fourth fourth exercise we discuss a fourth example. Okay, after that this we'll be discussing the exercise. The fourth example is that the set is given the form of rational numbers. Okay, rational numbers means which are in the ratio. So 3 by 4 and 4 by 5, 5 by 6 and 6 by 7. So this is given in roster form and we have to express in a set builder form. One thing we have to just take a is equal to, one thing we have to note that, so here 1 2 3 4 5, these are the natural numbers, positive natural numbers, and so these are incremental, plus 1 1 incremental. So 1 plus 1 2, 2 plus 1 3, 3 plus 1 incremental. So incremental means what, n plus 1. These are the n, and these below terms are n plus 1. Therefore we can write x ratio x is equal to, our numbers are n numbers, and below numbers are n plus 1. Okay, we can write. Definitely we can write. And where n is natural numbers, where n is natural numbers, and where n is natural numbers and n lies between 1 to 6. Okay, n lies in between, n is lies in between 1 to 6 means n is equal to 1 or equal to 1 to n is equal to 6. N is lies between, if we don't write this equal sign, then it will become as 2 3 4 5 only, between 1 to 6, 2 3 4 5. If we write the equal sign, then 1 2 3 4 5 6. Okay, all six terms will become. Okay, understood. And the next problem, which is much more interesting, so this we need to match the left side to right side. Means the left side is given in the roster form and right side is given in the set builder form. This is in set builder form and these terms are in roster form. Okay, so the here the word is given, here the set is given. So this is matchable to this number, definitely, because here p is there, r is there, I is there, n is there, c is there, c is there, I repeats, p repeats. Therefore here I and p we have not written again, and a is there, a is there, and l is there, l is there. Okay, I and two terms are repeats, two elements are repeats here. 1 2 3 4 5 6 7 8 9. So these are the nines and two repeats, then 7. The two terms are repeats, two terms are repeats, 9 minus 2 7. So these are the 7, 1 2 3 4 5 6 7. Okay, then it is 1, it is 1. So this 1 means what? The answer of 1 is D. The answer of 2 is sorry, 0. So 0, where it comes? 0 here, if we put if we the divisor of 18. Okay, positive integer and divisor of 18. 0 will not be divisor of 18, and if we 0 put, then it will be not 0. It will not 0. If we put 0, minus 9 is equal to 0, and if we put 0 here, 1 will come. Okay, if we put 0 here, then 1 will come. 1 will come. 1 is equal to 1. Then right, this is the right answer. So second one is C. And third one we can write. Third one we can write as so 1 2 3 6 9 18. These all numbers will be divided to the divisible by 18. Okay, the 18 is divisible by all these numbers. Okay, divided by 1. Okay, 2 by 2 is also 2 nines are by 3 also, 3 6 are 18, 6 3 are 18, 9 2 are 18, 18. All these divisible by these numbers. Okay, then third one is 8. Third one is 8. And then fourth one is 3 comma minus 3. Okay, and fourth one is definitely B, because it is only one remains. And so if we put x is equal to 3 minus 3, put x square minus 9 is equal to 0, and put 3 minus 3, 3 minus 3 here. So 3 square is 9, 9 minus 9 0, and minus 3 of whole square minus 9 is equal to 0. Here minus 3, when we are squaring this one, it will come as positive number, and minus 9 is equal to 0. Okay. Okay, next we'll be solving the interesting, after discussing all the concept and some by solving some examples, we'll be try to solve the exercise problems. Okay, will be exercise problem. given in your textbook. Okay, here we need to justify that it is a set or not set. Okay, the first one is the collection of all months of a year beginning with the January. So which are the months? The which starts with the capital the letter J. So January is there, June is there, July is there. So if we write this one, problem one, we'll be getting set. Therefore, it is a set. It is a set. It is a set. And second, the collection of 10 most talented writers of India. So the second problem, collection is given. Collection means what? It is we feel uh, collection means we feel it as it is a set, but we have to write. We have to read the complete full sentence. Collection of 10 most writers. How 10 most writers of India? How we can identify 10 most writers of India? It is quite impossible. It is quite impossible. It is quite impossible. So and some by setting the some criteria also uh, we can able to identify 10 most talented writers in India. So therefore this may or may not be set. This may or may not be set. This may be or may not be set. When the when and also we can write the sentence when the list of when the list of 10 most talented 10 most talented authors or writers is given, then definitely it is in set. You write just this one. Okay, the given problem is not clearly specified, and this may be set or may not be set. Okay, and if the list of right authors writers given in a specific list, then it is a set. Okay, then third one is what? The third one is a team of 11 best cricketers, batsmen of the world. So the in cricket, the players are 11. Okay, the players are 11 only. Well, those are all best, and a collection of 11 members for the playing cricket. So it is a collection of 11 members. Then it is a set. Definitely, it is a set. And fourth one is that the collection of all boys in your class. So it is a collection of all boys. An additional specification is not given, therefore it is also set. And fifth is what? The collection of all natural numbers less than 100. Okay, less than natural numbers. The natural numbers collection of all natural numbers less than 100 is given. Okay, 100 is given, then means what? It is a set. It is a set. If it is not 100 is not given, if 100 is not given, it is our infinite. So this is infinite set. Okay. So the collection of novels written by the writer Premchand. Okay, the collection of the writer Premchand has written some novels which are we can countable, which are countable. Then four, therefore six is also set. Six is also set, and seventh the collection of all even integers. So the collection of all even integers are called uh, set. Okay, this is also set, but it is infinite set. And eighth one is eighth one is so the eighth one is collection of all question in chapters. Collection of all question in chapters is also set. And collection of ninth one is collection of all most collection of most dangerous animals of the world. Collection means we feel it as it is, but next we have to write this sentence. This sentence, most dangerous animals. It is very too difficult to identify the most dangerous animals in the world. That is additional specification is given. Therefore, it is not a set. It is not a set. It is not a set. Okay. Likewise, you have to identify when the problem is given to identify set or not set. And one more the theory I will going to explain here. Suppose a set V contains a vowel numbers A, E, I, O, U. of English alphabet grammars. So this A belongs to V means what? So A is an element of V. So if I will take B is does not belong to V. So here B element is not there. It does not belong to V. So that is the meaning of belong to and does not belong to. Likewise, we have to write here sign. So 5 belongs to A. It is right. And 8 belongs to A. It is not right. Not belongs. It is not there. And 0 is also not there. 10 is also not there. 2 is there. Belongs. 4 is there. Belongs. Okay, this is the meaning of that belongs. Next we write. Uh, Next we solve the third exercise. So the first one, the sets is we need to express these in the roster form because all in a roster form. So we need to express in a roster form. The first problem is given in a set builder form. We need to express in a roster form. And x is an integers. The x is lies between -3 to 7, and x is equal to 3. So they have given x is equal to 3. Then means -3 will come equal to given, then -3 will come. If it is not given equal, then -2 will come. It will start from the -2. So -1 and integers given. Integer contains 0, 1, 2, 3, 4, 5, 6. Okay, up to 6. So not equal given, therefore up to 6. So then second one is we have to write in curly bracket. Okay, second one we have to write in set roster form. Natural numbers which are less than the 6. The natural numbers less than 6 are 1, 2, 3, 4, 5. Okay. And third one is what? Third one is given x is a uh, x is a so the third one C. So here B is given. Okay, we have to write B. And x is a two-digital number such that sum of its digit is 8. So sum of its digit is 8. Two numbers are given and sum of its digit is 8. So means two numbers you take. So A and B are two numbers. A and B are two numbers. Take and sum of A and B will be 8. Okay, this problem is given. Up to what number? Two numbers. Up to two numbers. So then we have to write here two numbers as A into B. Two numbers in not A into B. We have to write together. We have to write. So two numbers. Suppose you take A is equal to 1 and B is equal to what? It has to come 8, right? And then 1 plus 7, 8. 1 plus 7 is 8. Then it is 1 7 number. A is equal to 2, sorry. And A is equal to 2. Then B is what? 6. Then it is 2 6. And A is equal to 3. And B is equal to 5. It will be 3 5. And A is equal to 4. And B will be 4. Then it is 4 4. And A is equal to 5 and B is equal to 3, that is 5 3. And I will write here, and A is equal to 6 and B is equal to what? 6 plus 2 8, then it is 62. And A is equal to 7 and B is equal to 1, this is in 71. And if I take A is equal to 8, this I cannot take this. Okay, up to here is over, because 8 plus here 8 we cannot take, because up to sum of digit is 8 is given. So here if I take b is equal to 1, then it will be 9. So up to here is over. Then this one I will be writing in a collection. How I can write C is equal to is a collection of, according to the problem statement, it is a collection of 17 26 and 35, 44, 53, 62 and 70. Okay, this problem is very important. It may be asked. This problem has been asked in many times in your examination. Now solving the fourth problem. So solving the fourth exercise problem. So we need to express this in the set builder form. Okay, set builder form. All these problem given in the roster form, we need to express in the set builder form. So first problem is given is 3, 6, 9, 12. Okay, if we clearly read this problem, we will be understanding 3 1s are 3, 3 2s are 6, 3 3s are 9, 3 4s are 12. Then we can write as A is equal to X. X is a multiple of 3. Multiple of 3 we can write. Okay, problem is over. And second one we can write as 2 4 8 2 4 8. You write it is B is equal to 2 4 8 16 and 32. So this will be in if we observe this one, we can able to write 2 1s are 2 2s are 2 3s is 8 2 4s is 16 2 5s is 2 5s is 32. So this will be in 2 raised to n. Okay, 2 is remain 2 is 2 is remain same in all over here, and power n is changing. N is changing. So therefore we can write here b is equal to x. X is equal to 2 raised to n. 2 raised to n we can write, where n is a natural number, where n is a natural number and n belongs to capital N we can write. Okay, okay, this. And next is okay, the next is problem third is given is 5 1 525. So 125 and 625, this is also in the same form. So as we observed that it is 5 raised to 1, 5 raised to 2, 5 raised to 3 and 5 raised to 4. Okay, 5 raised to 2 is 25, 5 raised to 3 to 125. So this is in the form of 5 raised to n, 5 raised to n. Then also we can write here c is equal to x is equal to x is equal to such that x ratio x is equal to 5 raised to n, and where is n is a natural number, and n belongs to natural number. Okay, this we can write. And the next is fourth one I will write here. Fourth one I will write here 2 4 6 and it continues. Okay, it continues means it is a natural number. Even numbers. Okay, 2 4 6. So it is a collection of all natural numbers. Then we can write here x is equal to, x is equal to uh, is a multiple of, you just write is a multiple of 2. And the last one, fifth, I will write here. Okay, fifth problem I will write here. Fifth is given is 1 4 9 and it continues 100. So it continues. Okay, it continues means what? We have to additionally here we have to write. So additionally we have to write. Uh, so we have to write. So here x is x belongs to n. We have to write the multiple of 2 is a multiple of 2 and x is belongs to n. And this also we can write as 1, 2 square, 3 square, so on. Here 10 square will come. Okay, then this will be this you take is equal to e x x. So here it is in the n square form. Okay, 1 square is 1 square of 1 is 2 square. It is n square. It is in the n square form. Is equal to n square form, where n is equal to where n is equal to or less than 10. N is equal to 10 or it is less than 10. Yeah, understood. Okay, next we come across this problem. So here we have to write in a roster form. Okay, in a roster form. So odd natural numbers. Odd natural numbers are what? 1, 3, 5, 7, so on, so on. Okay, so on. It continues. The roster form. And second one is b is an integer 1 by 2 of 1 by 2. So is 1 by 2 and 9 by 2 is given. So 1 by 2 is what? If it 1 by 2 is minus 0.5, 9 by 2 is 4. So we can write within the minus 1.5 and 4.5. So minus put here minus 0.5, then here 0, 1, 2, 3, 4. We can write like this also. The third one is an integer x square is equal to less than or equal to 4. Means what? If we take here c is equal to, then it will be 1 square is 1, 2 square is uh, okay, square 1 2 1 2. Okay, if you put the value of 1 is 1 square is less than or equal to 4, 2 2 square is equal to 3, 3 will not come. Okay, fourth one is a letter word of loyal. So we write loyal as in a roster form. So L is there, O is there, Y is there, A is there, and L last word it repeats. Then we cannot write. Okay, we don't want to write that L. And next one is fifth one is the fifth one is and fifth one is E is a month which are not having 31. Which month are not having a 31? Ajusan. Ajusan means what? April, June, September, November. These months are not having 31 days. Because you just remember that A in an Ajusan, April, June, September, November. And the sixth one, so here sixth one's consonant is given. So consonant which precedes K. Well, which precedes K means what? Which precedes K means what? The remaining. Okay. K before alphabets are nothing but a precedes. K precedes consonants. K precedes consonants. Previous one is K precedes consonants. Which are the consonants? So A is vowels, B is consonant, C is consonant, D is consonant, E is a vowel. We cannot write that one. A B C D E F G H I we cannot write. J. So this is J. Okay, up to J. Up to J we can write. Okay, this is an collection of B C D F G H I H J. The last problem is also same like we have solved in examples. So I will write here. Here left side is given in the roster form, right side is given in the set builder form. 1236. So 1236 is a one is a C, right? Because it is a divisor of 6, right? 6 is divided by 1, also 6 is divided by 2, also 2 to the, and 6 is also 3 to the 6 is 6. Okay, one is C, and second one is 2 3. So 2 3 are a prime number and divisor of 6, right? 2 3 is our prime number and divisor of 6. Then second one is 8. Second one is 8. So 2 3 are prime number and it is divisor of 6. The statement is correct. And third one is third one is D. By seeing this here, will understand mathematics. So M A T H, there M repeats, A repeats, T repeats, and I C S. Okay, I C S. And fourth one is 1357. It is natural numbers, natural odd natural numbers less than the 10. So it is B. Okay, okay. We'll next class we'll be going to discuss the remaining topics in the sets. So another two classes are required to cover. 2 to 3 classes are required to cover the complete syllabus of your sets. And thank you. Please subscribe the channel and share to your friends. Thank you.